in the triangle ABC, so ABC, the angle BAC, so BAC, this red angle here, is greater than the angle BCA, BCA, so this angle here in green. And P is any point on the bisector of the angle ABC. So here's the angle ABC, this angle here. This is the bisector of the angle, so it is the line that cuts the angle in half. And P is a point on the bisector. So bisect means to cut in half. Prove that the area of the triangle PBC, so PBC, so this triangle down here, is greater than the area of the triangle PBA, so PBA, so this triangle up here. Justify each step of your deduction. Okay, so step 1, as the angle BAC, so BAC, so this angle in red, is greater than the angle BCA, so BCA, this angle in green, the length of BC is going to be greater than the length of AB. And this is by the theorem which says that in a triangle, the longer side is opposite the larger angle. So if the angle BAC is bigger than the angle BCA, then the side that is opposite the bigger angle, so if this is the bigger angle, the side that is opposite is BC. And if this is the smaller angle, the side that's opposite is BA. So this side, BC, must be bigger than this side, BA. Step 2. If D is on AB, so here's AB, and here's the point D, with PD perpendicular to AB, so PD perpendicular to AB, there's our perpendicular symbol there, and E is on BC, so point E is on BC, with PE perpendicular to BC. So PE is perpendicular to BC, and there's our perpendicular symbol there. Then the triangles BDP, so BDP, so this triangle here that I've labelled as number 1, and BEP, so BEP, and I've labelled this as number 2, are congruent. So congruent triangles are identical, so 3 equal sides, 3 equal angles. And they are congruent by ASA, angle included side angle. So we have a common angle, which is the perpendicular angle, so PDB, that angle is a right angle. And we have BEP, that's also a right angle. We have this common angle here, because remember BP is the bisector of the angle, so these angles must be equal. And then we have the common side, which must obviously be equal because it's common. So we have this angle matching up with this angle. We have this angle matching up with this angle. So the third angle must automatically be the same as well, because if you prove that 2 angles are the same in 2 triangles, then the remaining angle must also be the same, because the angles in a triangle must always add up to 180 degrees. So we've proved that the 3 angles are the same, and we've proved that we have a common side. So we have angle, included side, angle, and then angle, included side, angle. So we have proved that the triangle 1 and triangle 2 are congruent by ASA. So hence, the distance from P to D must be equal to the distance from P to E. So this green line must match up with this yellow line. So they must be equal because these two triangles, 1 and 2, are congruent. So 3 equal sides, 3 equal angles. So part 3. The area of the triangle PBC. So PBC, so this triangle at the end here, is going to be half times BC times PE. So we know the area of a triangle is half times base times height. So it's going to be half times the base, which is BC, times the height, which is PE. So half times base times height. And the area of the triangle PBA, so PBA, so this triangle at the top here, is also going to be half times base times height. So half times AB times PD. So half times AB, which is the base, times PD, which is the perpendicular height. So half times base times height. By the definition, which says that the area of a triangle is half the base by the height. As BC is greater than AB, so remember BC is greater than AB, and we proved that at the very start because of the theorem which says that in a triangle the longer side is opposite the larger angle. Then BC multiplied by PE must be greater than AB multiplied by PD, because remember PE and PD are equal. So we proved that up here. So if BC is greater than AB, then multiplying each of those by the same length, you're going to be left with BC times PE still being greater than AB times PD, because we're multiplying them by the same length. It doesn't matter what the length is, we just know it's the same. So therefore, multiplying in a half on either side as well, a half times BC times PE will still be greater than a half times AB times PD. And a half times BC times PE is the area of triangle PBC. So triangle PBC. And a half times AB times PD is the area of triangle PBA. So PBA. So we have proved that the area of the triangle PBC is greater than the area of the triangle PBA. And that's what we were asked to prove.